Recording in progress.
Good afternoon, Michaela.
Hi, how are you?
I'm good, I'm good. I'll just wait for everyone else to join. Hey, Jonah.
Hey,
We're just waiting on a couple more to join.
okay. Before we start, could I just
Yep.
ask a question about one of the homework questions?
Sure.
It was 28, I believe.
28, yep.
28D. It was like, do you want me to like get it up or have you?
Yeah, no, you can go ahead. I have
Like,
the
should I? Oh, you have it? Okay. It's just like find like the values of k for which there are two distinct positive zeros. Is that it?
Yep.
So I found the positive zeros, but I don't know how to find like the distinct ones. Like how do I know if they're different?
So what did you end up finding as your answers?
So I end up finding between 1 and 3,
Yep.
k like not exclusive. I mean not inclusive.
Yep.
Uh, k is like the zeros will be positive or the roots will be positive,
hmm
but it says distinct, which means that they have to be different. So I don't know how to like determine that if it's even part of the question.
Um,
It was a 1 marker, so it might not be, but
the distinct part of that comes from
oh, actually, it was a 4 marker.
the distinct part of that comes from your original solving of the discriminant. You're solving for the discriminant to be greater than 0, because if it's greater than 0, you must have two roots. Whereas if you have the case where it's greater than or equal to 0, you can have the case where you have one root. So you don't
So
need to explicitly do anything extra for distinctness if you've set up the inequality correctly. But you will have a bit of a narrower bound than what you got. So the answer should be between 2 and 3 rather than 1 and 3. I'll just pull up the solution real quick for you.
yeah, could you? Yeah.
Let me just get on my slides. Okay. It's this question, yeah.
Yeah.
Okay. So, all right. So with this one, yeah, we'll just start with discriminant. So b squared minus 4ac. And I'm choosing strictly greater than 0 to have two distinct roots.
Yeah.
In this case, your b is going to be the 2k minus 1. So just take it as 2k minus 1 squared minus 4 times just 1 and minus k minus 3. It's greater than 0. Then just expanding and simplifying, you're going to get 4k minus 1 squared plus 4k minus 3. That's just taking this negative out there. Okay, this is greater than 0. And I'll just spare you the expansion because
Okay.
it's just expanding. But once you expand and simplify, you're going to get to 4k squared minus 4k minus 8 is greater than 0. And then you factorize out 4, you get k squared minus k minus 2 is
Wait, is it a minus 8k?
this doesn't have a k in it. This is just
Sorry,
constant k.
minus 4k because there's two.
Wait, maybe
If
I
you
will
multiply,
just
yeah,
I'll
it is
just
8k, I think.
I'll just show you the expansion. So you get 4k
It's plus
squared
plus 4 minus 8k.
minus 8k plus 1. So this is just expanding that term. Then you get
Oh no,
plus
plus 4.
oh yep.
Plus 4. Yeah.
Yep, plus 4k minus 12 greater than 0. You get 4k squared, and this becomes minus 4k, and this becomes minus 8.
Oh, you did. Okay, right.
And then yeah, we get to the same point, like so. And then from here, you just divide the 4 out.
Yeah.
Okay, and then factorizing this, you're gonna get k plus 1, k minus 2 greater than 0. Or you're gonna get, so k minus 2 greater than 0, which gives you k greater than 2, or you get k plus 1 greater than 0, which gives you k greater than negative 1. Is that correct? One sec. Yeah, that should be correct. Okay. And the last part is looking at sum of roots and product of roots, which is, if you look at sum of roots, so alpha plus beta, because it tells you you have distinct positive roots, if you sum your roots, these must both be positive. because we've explicitly said that they're
Oh,
both distinct and positive.
right.
So,
Okay.
so this has to be greater than 0.
Yeah.
Okay. And if we sum our roots, where our roots should be, 1 sec. Um,
I did this part and it's 2k minus 2 times k minus 1, and
yeah,
the other one's k 3 minus k.
yeah. Oh, right. Yep. Yeah, yeah. It's just looking at the coefficients.
Yeah.
Yep.
So it's 2k minus 2.
Mm-hmm. Or you can just say remove the 2, just divide the 2 off, and you get k greater than 1.
Yeah.
And then also if you look at if it lets me draw, if you look at your product of roots, it's also going to be positive because you're multiplying 2 positive numbers. So alpha beta is greater than 0, and it's going to be equal to minus plus, so minus k minus 3. Right, so this is minus k plus 3 is greater than 0, or
K
minus,
is less than 3.
yep, or k is less than 3. So you want to look at your most constricted bounds now. So you have here k greater than 2, k greater than -1, k greater than 1, and k less than 3. So the upper bound has to be 3 because that's the only upper bound you have. So
Mhm.
we know that this is going to be the case. It's now what is our most constricted lower bound? So
And it's just 2 and 3, right?
yep, because if you say it's -1, like here, then this, you're like not satisfying this where k has to be greater than 2. So yeah, it would be this.
Right. Okay.
Yeah.
Okay. Thanks.
No worries.
And it was just that and one other question for homework, right?
Yeah, because we basically went through everything during the lesson.
Yeah, yeah.
This one will be quite different. The questions today are all like really long.
Mm.
Honestly, I might just get started because otherwise we might not even have time. But
Yeah.
I'll just call campus, let you know, let them know, and I'll be back with you in like 2 seconds.
All right.
All right, we'll get started with the lesson. Okay, so for today, we're going to be doing rates and projectile motion. So just show you guys where we are in the term. So we'll be doing this lesson today. We're not going to be doing the HSC mock exam review this lesson. We'll do that next lesson. And so as homework for this week, I'm going to have you guys do that mock review exam. Because I'm going to make you guys do that, I'm not going to give a lot of homework for projectile or rates. I'll just give you like one hard question for each, and then just the exam paper, and that's it. But that's basically all the admin stuff. So we'll actually just get into the lesson because it has been a bit of time. I'll just get up the whiteboard. Okay. So we'll start off with rates, and then we'll go into projectile motion. Okay. So just some intro theory before we go into questions for rates. They all are virtually reskins of the same question. It's just around integrating and differentiating the right things and accounting for your right constants. So using your like right initial conditions. And outside of that, the main trick to these types of questions is going to be chain rule. And what I mean by that is, for example, if you have a question that is looking for, let's say, ds dt, where S could be like concentration of salt, which is a question we're going to go over later. You could rewrite this as ds dx, so the variation of salt in x times dx dt. Because you may not know what ds dt is, but you could have s as a function of s as a function of x rather, and this probably will be given to you here. If I scroll down. So this will probably be given, and this can probably be found. And then using that, you can find what you're actually looking for. But that's just about all there is to the actual theory. So we'll just jump right into questions because these are quite time consuming. I'll write them out. Okay, so first question, we have a 500-liter tank, which is initially empty. So during some rain, the rate of volume change is, we'll call it V, is 100 minus T squared, and this is in liters per hour. So we want to know how much water is in the tank after 9 hours. I'll give you guys a couple seconds to think about it. I'll get Michaela to help me through this one.
So I'd probably start with writing dv on dt equals 100 minus t squared.
Yep.
and then just integrate that.
Sure. So are you gonna move anything over before you integrate?
Oh, the dt.
Yeah. Okay. Integrate. Are you gonna have any bounds or no bounds?
Oh no.
Okay.
Oh no, I'll do 0, 0. Like when v is 0 on the bottom, t is 0 on the bottom, and then v is x.
Oh yeah, you can just call it capital V.
Okay, capital V, and the other one is 9.
Sure. Okay. So left side's gonna be.
V.
Yep.
Yep. And then in square brackets,
Mhm.
100t minus a third t cubed, or t cubed on 3,
Sure.
and then 9 to 0.
Mhm.
And then sub that in, which is 100 times 9 minus, yep, whatever, minus 0.
Yep. So
Uh,
plug that in, see what you got.
657.
Yep. Indeed, it is 657 liters. Okay. Is that gonna be your answer?
Yeah.
Okay. So read the question again. There is a trick. That's my hint to you.
Oh, it's 500 liters.
Yeah.
Oh, so is it just 500 liters?
Yeah. So yeah, exactly. The volume's just gonna be 500 liters, and then you can just clarify there'll be 157 liters of overflow. But yeah, the end answer would be 500 liters. Okay. So couple follow-on questions from this one. So we'll call this part 2. When does the rain stop? When do you think the rain stops?
When the rate of change is 0.
Mhm.
So 100 minus t squared equals 0.
Sure.
T squared equals 100. T is plus or minus 10, but t is greater than 0.
Yep.
So it's just 10.
Yeah, perfect. Okay, and last follow-on question. Should be pretty straightforward now that you have all the data. When does the tank first reach 500 liters?
Sub in 500 to the integrated function.
Mhm.
So I'd probably do 500 equals 100t minus t cubed on 3.
Yep.
And then just,
Solve for t.
yeah.
Yep.
Minus t cubed. Bring that all to one side.
Yep.
So t cubed minus 300t plus 1500 equals 0.
Would there be a plus C or no?
So we went through the method where you took bounds, so we didn't have to deal with a plus C. Alternatively, if you didn't take bounds, what you could do.
But we don't know the bounds for this, so
Okay, yeah, so there's kind of like a for you trick, but the way we bypass it, we know at the start both of these are 0 of because we know it's initially an empty, so volume will be 0 when time is 0. And then we also know that we're looking for 9 hours. That's our like target time to find what our volume is. And so what you can kind of do, it's a bit cheese, but you can just say our volume is V. And that's what we're solving for. So you can pseudo put in bounds.
No, in the one we're talking about.
Oh, and the one down here.
Yeah, yeah, yeah.
0.
Right.
It's empty.
Yeah.
It's the same principle. So down here, if we were to write
No,
in,
no, I get it. I was just asking, like,
yeah,
yeah.
yeah, it would say that if it was like going from the integral form, it would look like this. So it would be going from 0 to t 100 minus t squared dt. And it would be the same process. Now we can just say 500 equals 100 t minus t cubed on 3, t 0, and then you're just going to get 500 equals 100t minus t cubed 3, like so. But plus C method is equally as valid. This way is just like a little shortcut. All right.
What would you do after that?
Let me have a look myself.
Have I done something wrong?
No, that's correct up to there. Okay, so from here. Yeah, that is quite annoying to factorize. I think from here, honestly, the best way would just to be trial and erroring different t's here. So you could just like plug, for example, it's obviously not gonna be like 1 to 3. So let's like try 4 first. So then doing that, you're gonna get 364. So it's not 4. Try 5.
No.
Not 5.
Um,
And then try 6.
nah.
Actually, wait. Hold on. That is weird.
Excuse me.
Interesting. Yeah, that is weird. I'll come back to that because that should be, it should be somewhere in the sub-tens. That's weird.
I just put into ChatGPT and I don't think there is a sub-10 answer.
Yeah, which is weird.
Oh, actually, no, there's like 5.57.
Yeah, that's the correct answer.
Okay, right, yeah.
I just don't know why it's not showing up.
But like, how do you do this? This looks really,
There's like a really cancer algebraic re-expression to do it.
it's like 20, it's like A cos omega on 3 or something. Minus,
I have a slightly different way of doing it. I have like something cubed minus 300 and then dividing it by something. That's yeah, I think this is just a trial and error question though. Like, well, up to this point.
How
But
are you
I'll
supposed to just guess 5.5?
you can't, but you can't, yeah, you
yeah,
can't
you
trial
can't,
and error that.
you can't. I'll come back to see if there's a clean algebraic way to do that.
I don't think there's a 3-unit way of doing it.
I don't believe so either. Okay. Yeah. I'll put a flag on this and see if I can find a nicer way to do it. Okay. That's the end of that question there. So on to the next one.
Are these from the like book?
No, they don't have resources for motion and rate, so these are my own
Oh,
formulated questions.
right. Okay.
Okay. So next one, question 2. So for this one, we have a block whose sides, so this is rectangular block for clarification, whose sides are in ratio of 1 to 2 to 3. So it's always in this ratio. It starts at 10 by 20 by 30, all in meters. And it's going to melt, so pretend it's like butter, for example. It melts such that its surface area decreases at a rate of 3 meters squared per second. Okay. The question is, find the time taken to reach 1 by 2 by 3 meters.
Okay.
And then as a little sub question for part 2, so we'll call this part 1. What is going on? Find dv dt at that time. So I'm gonna get Jonah, you to help me out for this one. Are you-
Okay, so
Yep.
I've wrote down like relevant. So I just have the surface area,
Mhm.
which is dv equals 600.
dv equals
Sorry, like the surface area.
So ds we'll call it.
ds, sure, yeah.
Yeah.
And wait, no, is that ds or that's just s, right?
Oh yeah, so you're saying
Yeah, yeah.
yep.
And then ds on dt is 3.
Is it 3? Careful.
Hold on. -3.
Yes.
Oh yeah. Um, and so and
What
I
are some
also
other
just
things?
I also just have like x, an x
Yep.
value for like how much each ratio is like multiplied by. Yeah.
Sure. Okay. So I will, if we're to draw that as a diagram, let's say it's like this.
So it's like 1x, 2x, and 3x.
Yep, exactly.
Yeah.
So, okay, this won't be in ratio. This won't be to scale, but
Mm.
bear with it. Yeah, so we'll call it x, 2x, and 3x as our dimensions because that
Yeah.
accounts for our ratio of 1 to 2 to 3. Perfect.
Yeah. And
Okay.
then
What else do we know from the starting information before we
so
get into
x equals 10 when it is
Mhm.
at the start.
Yep.
So that's like dx. Oh no,
Okay, wait.
is it?
You're on the right track with originally thinking about how x is 10. Think about what we're trying to solve. We are trying to solve
When
okay,
x is 1.
kind of, but what are we looking at right now?
The time it takes for x to reach 1.
That's true. But what other parameter I'm circling right now?
Oh, the surface area to reach 6.
Yeah. So what's our starting surface area?
600.
Wait, is it? You're
Yeah.
gonna have 10 times 20 times 30.
Oh, 6,000?
Yeah,
Yeah.
yeah, 6,000.
Sorry.
All good. So this is gonna be 6,000 meters squared. And then
Yeah.
when we end, we get x equals 1. So we'll call it S final. Is going to be 1 times 2 times 3, which is 6 meters squared. Okay. What's a way of expressing our surface area in terms of this x?
Like 1x times 2x times 3x.
So that's volume.
Oh, surface area. Oh,
Yeah.
yeah, right.
Yeah.
Hold on. A block whose start?
So
Oh,
think the whole
yeah.
block's surface area.
Okay, wait, so it's 2 times 2x times 3x,
Sure.
and 2 times 2x times x, and 2 times 3x times x.
Yeah. Okay.
Which is,
So,
yeah.
yeah, I'll just expand it for you. It
Okay.
is 22x squared. Okay. So we have this now, and from here, okay, so we know ds dt equals -3. We can also say that, so we want to find, yeah, so from here, our end goal is to get an expression for dx dt, ideally. So
Right.
one
Does it
way,
also help having the initial surface area?
I'm not so sure at this stage. It might not.
Okay.
But going from here, if we chain rule this, we can write this as ds dx times dx dt. Would you agree?
Yep.
Okay. And what is ds dx?
ds dx is the rate at which x changes. Oh, no.
More so
Wait,
numerically.
do we have it?
Well, we just found something that can be used to find it. So look at what we just solved in the previous
Was
line.
it 22x squared?
That's s in terms of x. Now differentiating.
Oh, right. Okay. So it's just 44x.
Yeah, just 44x.
Oh, okay.
So in place of ds dt, I'm going to put -3 because that was given. ds dx is going to be 44x, and then we just left with dx dt. Okay, so rearranging this, we'll get 44 dx equals -3 dt.
Mm-hmm.
Okay, and we'll just integrate this like
Is
so.
it not 44x dx?
Yep, you're right. Yep, indeed it is. So integrating this is going to give you 22x squared. And on the right-hand side, it will give you -3t. And we'll do the plus c method for this question. So you get -3t plus c. And do we have any conditions that we know that we can set to find plus c?
Yeah.
Mhm.
Like what it starts at?
Yep.
The time starts at 0.
Yeah, it does. And what is x going to start at?
And it started at 10.
Yep. So plugging that in, we'll get, so 100 times 22, so 22,000 equals plus c. So c is just 22,000, right? So then we're going to get 22x squared equals minus 3t plus 2200, like so.
Wait, you found X. Sorry, how'd you find C? Did you
So
just
I just plugged this into this equation. So plugging the t equals 0 cancels this term out.
Oh yeah, right. Okay.
Yep. And then plugging the x equals 10 makes this thing 2200 because 10 squared is 100. So it just becomes 100 times 22, which gives you this.
Okay.
Yep. So now I've just plugged the c value into this equation again, and I've just written this out here. And if you remember,
We're trying to find when X equals 1. Sorry.
yes,
Yeah, that's
yep. So now
s-
just let x equal 1.
22 equals minus 3.
So what is your t going to be?
726.
Yep. And what unit of time is that going to be in?
In seconds,
Yep. Why do you say so?
because that's the initial meters per second. That was what it
Yep.
said in the question.
Perfect. Very good. Okay, that is correct. So that's part 1 done. Now let's try part 2.
What was this? Find
So
the
this is to find dv dt at well, t equals 726.
so dVdt was 44x.
So remember that was okay. I'm
What
gonna
was it was -3, right?
no, it was not. So I'll propose you a different start.
Sorry, yeah.
Can you find from our diagram, if I don't draw there, how can I express my volume in terms of what I have here? It's what you originally said to me. How do I find volume with x, 2x,
Oh,
and
like
3x?
x times 2x times 3x.
Yep, exactly. So that's just going to give you 6x cubed.
Mhm.
Okay, so I'll just bring this back down here. Okay, so that's going to give you 6x cubed.
Oh, when it says when it's dV on dt, that means volume, right?
Yes, it does.
Oh, I thought it just okay, right.
Yeah,
Whatever.
all good.
Yeah.
So how can I chain rule my dv dt?
So dV dt equals dV on dx times dx on dt.
Yes. Why did you set it up this way?
Because that's how it's supposed to be. So
Yep, true. But
like
the
what do you
thinking
want?
of why is because you've found v as a function of x. So you can
Yeah.
find dv dx. That's what informs this choice.
Yeah.
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 Okay, yeah.
So that's 6x cubed. Sorry, 6x, yeah, 6x cubed equals wait, you said we found dV on dx?
We found v as a function of x. We have yet to diff it.
V oh yeah,
So we need to differentiate it now.
wait, I'm getting lost.
Okay.
So that was 6. So that's 18x squared.
Yep. 18x squared. And what about dx dt? Do we know dx dt?
We have that from the last one, which was minus 3t plus c.
Let's see. Minus 3t plus c. Kind of. There's an easier way. it's not exactly correct what you said. So we can actually just get it straight from here.
Hmm?
We can get dx dt straight from here. So we have minus 3 equals 44x times dx dt.
Minus 3 equals 40. Yeah.
Yeah, if you just follow the screenshot, you'll see what I'm looking at as well.
I keep forgetting to do that.
You're
Wait,
all
so
good.
wait,
So this is
yeah.
from the previous part. So now if you just rearrange this, you can just say dx dt equals minus 3 on 44x.
Oh, right. Okay.
Yeah. Okay, so then just plug that in. So going down here. So minus 3 on 44x. Okay, and that's just going to give you minus 27 on 22x. And we're looking for, at the time 7:26, what is x at that time?
Wait, X at the time was 7:26.
That was the time. What was X?
It was 1.
Yeah, it was just 1. So
Yeah.
your end answer should just be minus 27 over 22. And that should be, in terms of units, should be meters
Yeah.
cubed per second. So this is your dv dt at that time.
All right.
Yep. And that's the end of that question.
Sorry, I
Good
just had
job.
a question about the first part. I did it a
Sure.
different way.
Mhm.
Is it also valid? Like I sort of did the. Can you see that? No, it's blurry.
Oh, you can just explain your method.
Yeah, like I found the initial surface area, like in terms of numbers, like not in terms of x, and the final surface area, and then integrated dA on dt equals -3, and then I just plugged in the limits, like the boundaries, with like when t equals 0, the surface area is 2,200, and then when t equals like t unknown, surface area is 22, and then I still got the same answer. Is that okay?
I mean, if we got the same answer, then yeah, it should be.
Okay.
Like usually there's more than one way of doing these types of questions.
Okay.
Okie dokes. The slightly more complicated one now. Okay. So for this question, we have a tank that stores 475,000 liters, and it starts with pure water. Okay. And into this tank, there's an inflow of 5,000 liters a day of flow with 1 gram per liter of salt water. Okay, and there's also an outflow of 5,000 liters a day. Okay, so first part of this question is, I guess, yeah, sure. First part of this question is find an expression for the amount of salt in the pool. Okay, so Michaela, I'll get you to help me with this one. it might be useful to do a diagram first.
Okay. Mm. So if there's 5,000 liters a day flowing in, and 1 gram of that is salt water,
Mhm.
mm,
You can keep thinking. I'm just gonna draw a diagram.
yeah.
So let's start by letting the amount of salt, we'll just put it in grams, be m. So let's find dm dt. So what does this mean physically?
Like how much salt
Mhm.
is getting added or removed every single day.
Yep. So that's exactly right. So let's look about how much salt is added per day.
Yeah. Um, 1 on 5. Oh, 1 liter.
Um,
Oh no. 5,000 grams.
yeah. So we have, it's because we have 5,000 liters per day times 1 gram per liter. So we're gonna get a total of 5,000 grams. So I'll just write that in a different color. So this will give you 5,000 grams. And what about salt removed per day?
So that'll be um
So what's our outflow rate?
5,000 liters a day.
Yep. So what do we have left to find?
How much salt per liter?
Yeah, so our concentration.
Oh, so like 475,000
Mm-hmm.
divided by M.
Close, really close.
Oh no, the other way around.
Yes.
Yeah.
So it's the total grams of salt divided by your total liters will give you that concentration. Okay. So now we have this. If we simplify this down a little bit, you're going to get what the hell? One sec. So if you simplify this down a bit, you're going to get dm dt equals, we'll just call it 5,000 minus, and then 5,000 over 475,000 is going to give you 1 on 95. So just call this m on 95. Okay. And from here,
Just integrate.
on.
Just integrate.
Yep.
dm equals 5,000. Oh, hang on.
Wait, oh wait, no, I realized why. So the question is not for amount of salt, it's for concentration of salt.
Oh,
So what we've done so far is still on the right track. But so now we're up to here. We need to think of how to express concentration.
Mm.
So we'll let concentration be C, but how we express it.
Wait, so when the outflow of water comes, does it take out the salt as well? Or like some of it?
Yes, that's why we
Okay.
have the M over
Yeah.
475,000. That's that concentration.
Um,
This is a hint. That's that concentration of salt.
yeah, yeah.
So how might I express concentration then, given what I just said?
Mm.
What was this term here?
The concentration.
Yeah. So what am I going to say C is?
M on 47500.
Exactly.
But 475,000.
Yep. Okay. Agreed. So,
Is that it?
not quite. Okay. So from here, we're gonna get, hold on. Hold on a second.
Is it something like you multiply that by 5,000? Sorry, you multiply that by 4800000 and then you like
I'm seeing if I can re-express dm dt in terms of DCs. So something like dm dc times dc dt. And then I can write this as 1 over dc dm times dc dt. Okay. And from up here, if I take dc dm, I just get 1 on 475 quad 0 or triple 0. So then this is taking 1 on this whole thing, which is just going to be 475 triple 0 times dc dt. And because this is dm dt that I'm actually getting here, I can take the same right-hand side as above. So 5,000 minus m on 95. And now I've gotten to here. And let's see if I can solve from here.
wait, the M195 is from what?
From the dm dt expression up here.
So are we trying
Wait,
to
so
find
that
concentration in terms of T?
Yes.
Oh,
so M is the amount of salt
Yep, it is.
and 5,000 minus.
But we don't want m because we just want everything in terms of C's or T's. So we can re-express m. So we've said earlier, right, that C was m on 4,7500. So if you rearrange that, you can say m equals 475,000 times C. So rearranging this thing. So then you can replace m, which will give you, so you get 475,000 dc dt equals 5,000 minus 475,000 c over 95. Okay, and then let's see. So from this, if we combine the fractions here, so combining this as one fraction, so 5,000 times 95 you get 475,000 minus 475,000 C all over 95. And then just divide everything by 475,000. So kill these all off. And you're left with dc dt equals 1 minus C over 95. So this will be our expression for rate of change of salt in the pool. So essentially the difference once we got dm dt was just realizing that our expression for concentration was going to be m over 475,000, because that's your grams of salt over your total volume. And then from there, we had our dm dt expression, and we knew what the right-hand side was, but we're looking for dc dt, so we use this chain rule. And because we know what C was in terms of m, you could solve dm dc by solving dc dm and then taking the inverse of it, like so here. So this was just this, but then we wanted 1 on dc dm because that was equal to dm dc. So that gave you 1 on 457,000, which just gives you 475,000 rel. That. And then you get to plug that in over here. The dc dt is what we're trying to get at the end. And then the right-hand side was the same as for dm dt, because this whole expression is equal to dm dt. That was the whole point of us doing that chain rule. And then it was a matter of re-expressing what m was, because we said that C equals m on 475,000. So basically we said C equals m over 475,000. So therefore we could say m equals 475,000 C. And that's how I went from this to this here. And then from there, it's just combining the fractions, and then you get your answer. Any parts that were confusing?
Yeah.
Mhm.
So this is sort of like a theoretical, but
Yep.
if the question said if they poured a bag of like if there was like 5,000 grams of salt every day, like an intake of 5,000 grams of salt,
Mhm.
which is the same as the like
Yep,
yeah
like what we get net. Yeah, sure.
yeah. Is that the same as if there was no intake and outtake
If so,
of
if
the
we're
water? Because
so-
the
so what you're
water
saying is like purely we have just a tank. There's no
Mhm.
inflow, there's no outflow. Just every day we dump in 5,000 grams of salt.
Yeah. It's not the same because it's decreasing.
Yeah, it's not the same because here we have it's like offset by some removal of salt every day.
But doesn't that mean that this number, can you see my
Yeah, I'm looking.
wouldn't this be 475,000 plus 5,000? Because the concentration of salt in the water is that plus that. Because there's 5,000 liters of water added every day as well with the salt. So it gets added and then it gets subtracted.
So you're saying if you add 5,000 grams of salt, you're also increasing the volume by 5,000.
Yeah, so you're increasing the volume by 5,000 and then decreasing the volume again. So it's
Why are you
like,
decreasing the volume if you have no outflow?
no, there is an outflow. What?
Are you talking about this question or you like your theoretical question?
This question.
Oh, okay, yeah, this question, sure. So you're asking for this question with the inflow and outflow. Why do we just take volume to be constant at 475,000?
Yeah, yeah, pretty
Okay,
much.
yeah. So it's because okay, I don't know if you did chemistry, but it's a steady state. So what it means is because you're pouring 5,000 in and you're pouring 5,000 out constantly, your net volume just is never going to change. It's like, how to explain it? Like, if I was to like pour out my water bottle, okay.
Like I understand. Did you just
Um,
pour it? Did you just
yeah,
actually?
yeah.
Nice. Nice.
But yeah, it's like, if you obviously it's not going to be exact, but the assumption is that it is going to be like as you're exactly pouring out 5,000, you're exactly pouring in
No,
the same 5,000.
I
So your
get, I
volume just
get,
stays.
I get in a practical sense, but
Mhm.
um, like the change in salt, because the salt concentration before you pour it out, the salt concentration is going to be, um, it's going to be like, what is it, 5,000 divided by 480000. That's the salt concentration per liter, isn't it?
It would be M on the total volume, not
Sorry,
5,000.
M on, wait, what's M again?
M is our grams of salt in the tank.
Which is 5,000 to start with. Like, let's just say it's after one day.
Sure, yeah.
So that's 5,000 on 4.8.
Oh, 475. But yeah, I get your point. Yeah.
But like, this is before it's poured out.
Yep, sure.
And then after it's poured out, um, you're subtracting 5,000 times the salt concentration. So does that all just equal? Maybe I'm overthinking this.
Where are you getting your 4.8?
Because it's adding 5,000.
But you're also removing 5,000.
I know, but it's like not at the same time,
It is at the same time.
But then how do you know if the salt water is getting removed?
Well, that's why we take the concentration of salt.
No, I
Like
know,
not all of the salt is okay, yeah. I see your point.
do you see what I'm
How
saying?
do
Because
you
like
how do
if you
you
remove it
know?
before,
Mhm.
then no salt is removed. But if you remove it after,
It's an
then the
assumption.
salt,
It's an assumption you make.
yeah.
So the assumption that we're going to make in this question is that so we're taking this concentration, right? We assume that it's uniformly mixed. So that means we're assuming that everywhere in this pool has the same concentration of salt.
Mhm.
That is the assumption we make to solve this question, which is why we don't have to worry about like initially how you're not going to have any salt like coming out.
Right. Yeah, yeah, yeah.
So yeah, I see your point. Yeah. So the end thing is we assume uniform concentration.
Okay.
So it doesn't matter whether it's like which part of the water is flowing out. We assume all of it to have the same concentration.
Yeah, I'm not really thinking of it like that. I'm just thinking of um like even if it is theoretic, like as soon as the salt water touches the water, then it becomes the full concentration. Just like pretend that happened. Um,
Mhm.
I just yeah, I was just trying to understand like why it was because the water being subtracted
Yeah.
is like the same concentration as everything else.
What do you mean by the water being subtracted? It's the same concentration as everything
So
else.
like the water being added is 100% salt, like a gram of salt per liter. But then the
Yeah.
water being subtracted is less than that.
Yes, because it's mixing in with a whole pool of pure
Yeah,
water.
yeah, yeah.
So it would be a lot more like dilute. It would have a much lower concentration.
Hmm. I
But
think we
that
just move on.
okay, yeah.
Yeah.
It's okay. We have Q&A at the end if you want to ask again.
Yeah, okay.
All right, we'll move on to projectile motion. Okie dokes. Yeah. Oh yeah, and just for part B, we can maybe circle back to this if we have time, but it's just for puppy, it's find C after 30 days. And it's just going to be, it's pretty straightforward compared to the first part. It's just rearranging this to get C.
All right.
Okay, so just some quick run through stuff with projectile motion. There is a little bit. So the key to projectile motion is breaking down your velocity, or like breaking down your motion into x and y, or x dot and y dot, and x double dot and y double dot. This is velocity. This is displacement. And this is acceleration. And key part of it is recognizing that these are separate. So what happens in the y-axis does not influence what happens in the x-axis, and vice versa. So for example, actually, that's honestly there just to say that. With these questions, you always have usually an initial like trajectory or velocity. When in this instance, you have like some force. But after this point, there's no force acting. So there's no force acting during flight except for gravity. So your x double dot will be 0 every single time because you don't have any force acting in the x direction. So because in 3, you don't deal with air resistance. So this is going to be 0. Whereas in the y direction, you're always going to have gravity acting. So you're going to have negative g as your acceleration in the y direction. Some key things that they always ask you to solve in these questions. So one is range. So to solve for range, you're thinking at this point here. That's when y is going to be 0. So you set y to be 0, you solve for time, or TR, which I call time of range, and then you plug in to the x coordinate or the x displacement to get your range. The second one is max height. So graphically, it's looking at this point, which if you think about it, it looks like a stationary point, and it is exactly that. So to solve this, you let y dot be 0. Reason being is because your velocity, so if you think about your velocity in like the y direction, if I like launch something in the air, before it comes down, it hits like a point of rest before it starts decelerating. And that point where it rests is always going to be at the top. So that's where you get y dot equals 0. So then from here, you solve TH and you plug time of max height into y to get the max height. And your last thing is going to be your angle of projection or your angle of incidence. So that just means I chucked it at this velocity. What's my angle that I chucked it at? Or it's coming down, like for example, this is the path. What is alpha here? And you're going to find alpha using velocities. So for example, in this case here, you'll have like this, you have x dot, y dot, and alpha. And you can say tan alpha equals y dot on x dot. Okay, and the last thing is inclined planes. These are like some of the hardest questions you can get in extension 1. But generally, so they're going to look like this. So call this T, O, R, X, Y. And it launches like so. Okay, yeah, it will look something like this. And to solve these types of problems, the general approach is you treat the inclined plane, like so this, as if it were flat. And you solve in regards to that. And then you basically, once you get this value, you then like relax that assumption and solve for x and y. But we'll explain that through an example. It's hard to say theoretically. Okay, we'll jump into a question. All right. Okay. Oh, what the hell? Okay, I'll give you guys a second to read that while I paste in the rest of the question. All right. So, okay, I'll get you to work with me for this one. So we're starting 2 meters above the ground, velocity of 30 meters per second squared, or 30 meters per second rather. 5, we're shooting it downwards or throwing it downwards, and we're given these starting equations. Okay, we take the origin to be where he's thrown it from, and the ground to be -2. Okay, how are we going to prove the motion equations here?
Okay, so I'd start by writing initially, like what's the velocity, like at t equals 0, x equals 0, y equals 0.
Sure.
So initially, the velocity is 30 cos 5.
For x?
Yeah.
Yep.
And y dot is 30 sine 5. Or negative 30 sine 5. And then start with horizontal equations.
Sure.
And then x double dot is 0. Then integrate that. X dot equals the integral of 0 dt, which just equals c.
Yep.
C1. And we know that initially x dot is 30 cos 5.
Yep.
So x dot equals 30 cos 5.
Mhm.
Then integrate that. X equals the integral of 30 cos 5 dt.
Mhm.
X equals 30t cos 5 plus c. But given that, given 0, 0, x equals, or c equals 0, x equals 30t cos 5.
Yep.
And that's that. And now vertical.
Yeah, continue
Y
on.
double dash is negative g.
Yep. What does it tell you G is in the question?
Oh, negative 10, sorry.
Yep.
Negative 10. Then y dot is the integral of negative 10 dt, which equals negative 10t plus c3.
Mhm.
And given when t equals 0, y dot is negative 30 sine 5.
Yep.
Y dot equals negative 10t minus 30 sine 5.
Yep.
Then integrate that again. Y equals negative 5t squared minus 30t sine 5. And just say 0.
Yep.
And that's that.
Perfect. Nice. Now let's find the time at which the ball strikes the ground. So what
Okay.
do I know when the ball strikes the ground?
So when y is negative 2.
Yep. Yep. So we know y equals negative 2.
Negative 2 equals negative 30t sine 5 minus 5t squared.
Yep.
Make a quadratic. 5t squared plus 30t sine 5 minus 2 equals 0.
Yep.
And then
You can just quadratic formula that.
30 plus root 30 sine 5 squared minus 4 plus 2, 110. I got 5.81.
Let me check that. I got 0.423.
Oh,
That's
Hmm.
30.
maybe I did it wrong.
Oh, I'll double check as well myself.
Oh, I'm in radians.
That might be why.
Ah. B plus root.
Yeah, I get 0.423. So just check where you've plugged in to a quadratic. The expression I have is minus 30 sine
Yeah,
5.
no, I'm doing it. I'm just
Yeah.
still in rad mode. I'll be getting there.
Yeah, yeah.
It's just taking a while to type it out. 30
Yeah, yeah. All good.
sine 5 squared minus 4, 5 times 2 on 10. There we go.
Nice. I'm guessing it was just a radians.
Yeah, 0.42.
Yep. Okay. And the last part, calculate at which angle the ball strikes the ground.
So I'd find the velocity at t equals 0.423.
Yep.
So x dot equals 30 times 0.423 cos 5. So that's 12.64.
Let me check. So what did you plug to get that?
30 times 0.423 times cos 5.
Are you solving for velocity or for displacement?
Velocity.
Uh-huh. So what was your velocity expression for x?
Oh, oops, wrong
Yeah,
one.
yeah, there's no, yeah, exactly. There's just no t in that one.
Yeah. So it's 30 cos 5. So it's like, it's 30 basically. 29.89.
Yeah.
And y equals
Hey, sorry about that. My Wi-Fi dropped out.
All good, all good. So we've just finished the first question. So just to fill you in on that. So we just set up the equations, starting with acceleration and then integrated, plugging in our initial conditions for velocity and then integrating again to get displacement. For part B, we wanted to find the time at which the ball struck the ground. So from the diagram, we knew the ground was at y equals -2. So we got our y displacement equation, the minus 5t squared minus 30t sine 5, and let that equal to -2, and then solve for t, and that gave us our time. And now we're trying to find the angle at which the ball strikes the ground. So our starting point is we know that it's going to strike the ground at 0.423 seconds. And Michaela's finding the velocities at that time.
So the x velocity is 29.89
Yep.
and the y velocity is negative 6.845.
Agreed.
And then let's say alpha is the angle.
Yep.
Alpha is inverse tan 6.845 on 29.89.
Yep. So I'll just sketch it out like so. But yep, perfectly correct.
And that's 12.9 degrees.
Yep. Let's me draw. One sec, my iPad's lagging. Yeah, yep. So it's tan inverse 6.845 over 29.89, which you said was like 13 degrees or so.
Yeah.
Yep. Cool. So just a little note. The question's a bit ambiguous, but the way I interpret the angle at which the ball strikes the ground is as this angle. It doesn't matter for this case because it's just alternate angles. But yeah, so I would just quickly say it's equal to 13 degrees because alternate angles.
Okay.
It's just a little note. It's still the same answer, but in case they nitpick.
So if it asks when the ball strikes the ground, the angle, is it always going to be that one?
Typically, yes. Typically, it's going to be the angle to the horizontal, unless
Alright.
it explicitly states the angle to the vertical.
Okay.
Okay, so on to the next question. So that you read through it. So Jonah, I'm going to get you to help me with this one. So just have a quick read while I'm pasting in the rest of the question. Okay, so we have rocket starting at a height of 5,000 meters, descends with a velocity of 2,000 root 2 meters per second, and it does so at an angle 45 degrees to the horizontal. Okay, so we know from the diagram that this is going to be 45 degrees, and it gives us these starting equations. So how are we going to find the maximum height that the rocket reaches? And also the time that it does so. Oh, you're muted, by the way.
When the when the vertical velocity is 0.
Yep. And how am I going to write vertical velocity in terms of x or y? In terms of like dots. So like in the previous question, like I called like for example x velocity or
Like-
like x acceleration x double dot, or like call the velocity I'm looking for here.
Wait, double dot. Sorry, I
So
didn't catch that.
yeah, I'll just show you here. So this means horizontal acceleration.
The
So
double dot.
yeah, each dot means a diff in respect to t. So this means basically dx squared d squared t.
So what's x?
Just your horizontal, like as in x and y. Just a horizontal distance.
Yeah, but wait, so x double dot is horizontal velocity and y double dot is vertical velocity.
Double dot is acceleration, because if you have
Oh.
two dots, you're diffing. Sorry, x is horizontal displacement. If you diff displacement once, you get velocity. If you diff it twice, you get acceleration. So, for example, x equals displacement dx dt equals velocity. And another way of writing that, the shorthand is just x dot, and then dx squared d squared t. So second derivative is acceleration. And the shorthand of writing that is x double dot. So in this case, what are we going to?
So x dot is x dot 2000 root 2 cos 45.
No, that's our starting velocity. So that starting velocity includes the x and y. So that's, for example, that's like v, and this is 2000 root 2. And then there's x, y dot, and x dot here. This is like a right angle triangle.
Wait, so we're trying to find y dot.
What is y dot going to be equal to at max height? So what's our horizontal acceleration? Oh, sorry, our vertical acceleration going to be?
2000 root 2 sine 45. Oh no, 0, sorry.
Yeah, why is it going to be 0?
Because it is. That's when it stops. When it changes. When it it's the peak height. Like what?
Yeah.
How should I explain this?
Yeah, it's because it has to get to rest before it can change directions.
Yeah, right. Okay. So and then we just put that into the equation.
Yep. So
So the y equation equals 0. Oh wait, do we diff the thing first?
yes. So
Okay.
let's diff it first.
So that's 9.8 negative 9.8 t plus 200.
Yep. And now we can solve. So what's this going to be equal
Yeah.
to?
So that's just t equals 0.049.
One second, because this is going to be equal to 0.
Oh, yeah.
And then solving from this, t is going to be equal to 200 on 9.8.
Oh yeah, sorry. Wrong thing.
Yep. So what's my time gonna be?
20.441.
Yeah, we'll just take it as 20.4. Now, what's my max height gonna be?
Your max height's gonna be if you put this into the y equation,
Yep.
so that's gonna be minus 9 t 20.4.
Let me know what
I
you got in
got
the Android.
7040.81 or 82.
Mm-hmm.
7040. And then wait, what was the question? Max height the rocket will reach when it
Yeah, you just found it.
oh right. Okay.
Yeah. All right, nice. Okay. Next part. The pilot can only operate the ejection seat when the rocket is descending at an angle between 45 degrees and 60 degrees to the horizontal. What is the earliest and the latest times that the pilot can eject?
So the earliest they can eject will be directly I want to say parallel to where it started or like on the other side.
Mm,
Or is that the latest?
try solve for it
Wait.
mathematically rather than logically.
No, I'm just trying to just trying to figure out how, because then I'll need to do the time it takes. Okay,
Because it needs to be between 45 and 60. I don't think you can predict it like such. Think how you find your angle.
like you find your angle by like
So
getting the components of the vertical and horizontal,
yep. What in particular of the vertical and horizontal?
the velocity.
Yes, exactly. It's going to be the velocity. So if I was to just sketch this quickly as a little diagram of what we're looking at.
So the velocity um at 45 degrees is going to be minus 2000 root 2.
Uh, so look at trying to decompose it into like your x velocity and your y velocity. So I'll rewrite the expression. So x velocity was actually
2000 root 2 cos 45.
not wrong, but
No, mine like on the way down
no,
when
no,
it's
you're not wrong.
descending.
There's just an easier way to do it.
I feel like this is the easy way to do it.
Look at what it gives you. It gives you the starting equation.
Yeah, that's what I'm doing. Oh,
It's not there. You can just differentiate
sorry.
200.
Wait, x equals 200. And wait, what's that going to give me?
So we're trying to look for x velocity. X velocity is, remember, if you velocity is just going to be this x diffed with respect to t. So it's basically going to be 200t diff with respect to t.
Oh,
It's like d dt
let's just
200t, which is going to be 200.
um that's interesting though, because I'm getting to that. Wait, I'm getting 2000 if I use the regular method.
Mm.
How does that work?
You're getting to
Because if I do this, I'm getting 2000, which should be how you do it. I don't know if that's flipped or not, but
cos 45. Um,
shouldn't it be?
yeah, I think I see what you mean. Because cos 45 is just 1 on root 2.
Yeah. And that's what it's supposed to, like, that's how you find the horizontal velocity.
Yeah. Okay, well, ignore that and just use the starting equations they gave.
Huh?
Okay,
After
yeah.
this time, equations of the rocket. That doesn't make any sense.
Yeah, okay. I see your point. That's like a problem with the question that they've provided. But okay, in that
Okay.
case, use it using the starting equations here.
Sure. Okay. Um, okay, so then it's 200. So the x velocity. Wait, what am I trying to find?
What about y velocity? What's the expression for that?
The y velocity is just the diff version of that, which was negative 9.8 plus 200.
Yep.
Um,
Okay. And
and so the
so
total
how do I
velocity.
find? Yep.
So when you find t, um,
Before
which
that, what
yeah,
am I like? What info am I given in the question that I'm looking for? Between what and
um,
what?
between 45 and 60.
Yep. So what I can do. So we're looking at a dissension angle of 45 and 60. So if I draw this as a diagram,
Yeah.
take this as x
But this
dot
is
y
weird
dot.
because I wouldn't need to find the y. I wouldn't need to find the time because of the question mistake.
You don't need to
Like
find the
that,
time.
are you certain that that's a mistake in the question? Because it does change.
Yes,
Yeah, right.
it certainly
It
would
should
be.
be 200 root 2, right?
Um, yes, as in your initial velocity should be 200 or 2, yes.
Yeah.
Um, yeah, that is a problem, but irregardless, you wouldn't be able to use that as your velocity for y because you need to account for gravity as well. So you will still need to use the motion equations to find t.
Oh, yeah, right, right. Okay, so
So, okay, from here, like from this diagram, we're looking for it to descend at an angle of 45 or 60 degrees to the horizontal. So if I consider, for example, this to be the horizontal, and it's descending at 45 to 60 this way,
mhm.
then the two angles I'm looking at are either going to be negative 45 or negative 60. Because if you think about it, we're going in the negative direction, like so.
Mhm.
Okay, so then what I can say, I know that just as a definition, tan alpha is going to be y dot on x dot. Just think from
Mhm.
this triangle over here. So if I say tan negative 45, I can say that this is going to be equal to minus 9.8 t minus 200. Notice I'm just plugging what we solved for y dot in terms of t.
On 200.
Yep, on 200, exactly. And what is tan negative 45?
10 minus 1.
Yep. So minus 1 equals minus 9.8 t minus 200 over 200. So if we rearrange that, what are we going to get for t? I'll let you solve that.
Yeah, we've got uh t equals, is it minus 9.8? Wait, t equals,
Sorry, how did we get negative 200?
Negative 200 where?
Like when you differentiated, it ended up y dash is negative 9.8 t minus.
oh yeah, it's positive, isn't it?
Oh, yep, yeah,
Yeah,
you're right.
positive. Yeah, that changes.
Yeah, you're right.
Oh, okay. So t does equal negative 9.8. Is that right?
No. Pretty sure it should be.
10, so negative 1 equals this.
Yeah, it should be
And
this.
multiply minus 200. Oh, right. Add 200. Okay, yeah. T equals
340.8.
What'd you get, sorry?
40.8.
Yeah, yeah.
Yep. Okay, so that's one of ours. And what's the other thing I'm gonna tan?
Tan
That is negative 45. What else is
tan
in between?
negative 60.
Yep. And same setup, minus 9.8 t plus 200 over 200. And what was tan? Negative 60.
It was minus 1.73.
Yep, so negative root 3.
Oh, oh yeah.
Okay, and then solve for t.
So it's like uh
Let me know what you got.
55.76.
Yep. I just put it as 55.7, but same thing. Okay, and last part. The pilot must eject when the speed of the rocket is no more than 350 meters per second. What is the latest time at which the pilot can eject safely?
So the
So,
pilot can operate ejection when the rocket is descending at an angle. So it needs to be between that still, right?
you don't need to consider that, no.
Really?
Yeah.
Okay. For the parachute to open safely, the pilot must eject when the speed.
Or like you kind of do need to consider it in the case you get multiple solutions. So you're kind of right that you need to consider it, but solve it first, and then what you do is check if your solution is between the two times that we said in part.
Wait, does it,
part B.
when it says no more than 350 meters per second, does it mean exactly 350 or like below that?
Exactly 350.
Okay. What was the latest time at which the pilot can eject? So
So how do we express speed in terms of x dot and y dot? So instead of our x, in terms of our x velocity and our y velocity.
um speed like
Give you a little hint.
like tan x on y or uh x squared plus y squared.
Yep, it's gonna be root
Root x
x
squared,
dot.
root x squared plus y squared, sorry.
Yep. So this is what speed is. Okay. And what do we know our maximum speed to be?
350.
Yep. So we'll say 350 is greater than or equal
Is it gonna be
to.
minus 350?
No. Why do you think I say no?
Because it's just speed.
Yeah. Speed only has a magnitude. If we
Okay.
attach a negative, then you're putting direction. So we'll say 350 is our absolute max. So thus our expression for speed over here must be less than 350.
Mhm.
So what do we know x dot was, or x velocity was from previous part?
It was 200.
Yep, so we'll say x dot squared is just 200 squared. And what was the y velocity?
It was minus 9.8 t plus 200.
Yep, so we'll just square that. Okay, now, okay, what we're gonna do, the maximum case, i.e. like the time, when we're gonna get the latest time, is when we take this to be equal, like the equal case.
Equal to 350.
So for simplicity's sake, we're just gonna say this. Okay. And then we're just gonna square both sides to get rid of this root. So, 350 squared is like 82500, and that's going to be equal to 200 squared. 200 squared plus 200 minus 9.8 t squared. And I'm just going to bring the 200 squared over here, just so I can avoid expanding this, because I don't really want to. Actually, this should not be 825. Just call this 350 squared. So 350 squared minus 200 squared. This is 82500. And then take this and then root. So take the plus or minus root of 82500. So it will be plus or minus 287.23. Okay, and then you solve your two cases. So first case, we'll take the positive. So 287.23. HT equals 200, 287.23. So you get negative 87.23. Obviously, this can't be an answer because you're going to get negative time. So immediately know this can't be the one. Solve the other case, so the negative case. So negative 287.23. We get 9.8t equals 487.23. And thus t equals 47.23 divided by 9.8 gives you 49.72 seconds. Now let's check if this applies to what we solved in part B. So is it between our earliest and latest launch or ejection times?
So we just substitute that into
You don't need to substitute.
sorry. What do we
So
do
we're-
then?
So we're just checking if
If
from
it's
part B,
between this
yeah,
and what?
between
This.
our earliest and latest start time. Is it between those two
Okay.
numbers?
Okay, so yeah,
Is it or is it not between?
it is. Yeah.
Yep. So therefore we can comfortably say that this is the latest time you can eject.
All right. Cool.
Okay. Cool. I think we'll go through one last example. Then Michaela, I'll get you to help me for this one. I'll let you have a quick read through. So two particles are projected at different times, both with the same speed v. The angles of the projections for the two particles is alpha, and the other one is pi on 2 minus alpha. The greatest height they reach above the horizontal plane is given by h1 and h2. And you can assume these are the displacement equations for an angle of inclination theta. So we want to show that for any angle alpha, that this is the case, where r is max range. How might we do this?
When it says R is max range, does that just mean if any one of those particles were projected? I mean, yeah, projected at 45 degrees, like the max one of them could go.
Yes.
Okay. Hmm. So I'd probably find X when theta's 45. Can I just assume that it's max when it's 45, or do I have to like,
No, you can assume that.
okay, I'll just assume.
Yep.
So
So
I'll
you're gonna
find,
solve for range first.
yeah, is that okay?
Yep, that's perfectly fine.
All right. So X equals VT cos 45.
Yep.
X equals VT root 2 all on 2.
Repeat that, sorry.
VT root 2 on 2. So just one on
Oh,
it.
yep. Yeah, yep.
Rationalized.
Yep.
And then I'll find what H1 is. Yeah, I'll find. Oh, wait. H1.
Okay, so gonna solve for h1, sure.
Yeah. Is there an easier way?
What is your approach? Oh, as in
Like-
like to do the question overall.
When H1, I'll just find what the X is when for
For
something the Y
h1,
value.
for max height, you just say like y dot equals 0. Solve
Oh, yeah,
for
right.
time. Yeah, and then you
And
solve
then
for y.
solve for Y. And then do the same for H2.
Yep.
And then see what I get.
Yes, exactly.
Okay. Y dash equals 0. So Y dash for the first particle
Mhm.
equals V sine 40, V sine A, sorry,
Yep.
minus GT.
Mhm.
And then when that equals 0, T equals V sine A on G.
Yep.
And then for H2,
So just be
oh,
careful. So you found time, we haven't found height yet.
height. So Y
Yep.
equals, yeah, H1 equals V times V sine A on G
Yep.
minus half
Yep.
G times V sine A on G all squared.
Yep.
And then just simplify.
Yep. So if we simplify it, what are we going to get?
V squared sine A on G minus V squared sine squared A on 2G, which is just, oh, have
Yeah.
I done something wrong? Isn't this supposed to be like another sine squared?
Let me have a look.
Hmm.
Yeah, this should be a sine squared here.
But oh,
Oh, right, I see.
oh, we forgot to times. I forgot to times by sine A.
Yeah, v sine a up
Yeah.
over here.
Okay, so that's just going to be v squared sine squared a on 2g.
Yep.
The final one.
Yep.
And I'll leave it at that.
Sure.
Now h2 y dash equals 0. Y dash equals v sine pi on 2 minus a minus gt. And t equals v sine pi on 2 minus a.
Before you go ahead, this is correct.
Just make it cos.
Yes.
Yeah.
So we'll just call this v cos alpha minus gt equals 0.
So t is v cos alpha on g.
Yep.
And then sub that into y.
Yep.
h2 equals v. Oh, I'll just write sine pi on 2 minus a. So that's the v sine theta. And then times the t, which is v cos a on g minus half g times v cos a on g all squared.
Yep.
Which equals v squared cos squared a on g minus v squared cos squared a on 2g. I just sort of simplified it.
Yep. Just check if your simplification is the same as the one I'm writing off the top of my head.
Yep.
Yep. Okay.
And then that just h2 equals v squared cos squared a on 2g.
Yep. Agreed.
Yeah.
Okay.
Now,
So what is h1 plus h2 going to be now?
h1 plus h2 equals v squared sine squared a on 2g.
Yep.
Plus v squared cos squared a on 2g.
Yep.
Take out v squared on 2g.
Good.
And then leave sine squared a plus cos squared a.
Yep.
Which just from the identity is just 1.
Perfect.
V squared on 2g.
Yep. So that's where we end there. Now we need to see how we can make range look like v squared on g somehow.
V squared on 2g. Gx. Let's look. Two.
So the way I would go about this is by deriving like a general range expression and then plugging the theta equals 45. So starting from how we find range, I just let y equals 0, and I'm just solving this for theta for now, but later I'm going to plug theta equals 45.
Oh, okay, so don't do that yet.
Yeah. So go from here and I'll let you do the working, see how you go.
So how did you get Vt sine theta equals half gt squared?
So that's from, I let the y equation here be 0.
Oh,
And then I
okay.
just took that to I just took the minus half
Other
gt
side.
squared. Yeah.
Right. So V sine theta equals gt on 2.
Yep.
And then let theta equals 45.
Yep.
Gt equals 2v times root 2 on 2 on
Sure.
g.
I'm just gonna write it
Oh.
as g root 2, but same thing.
Oh, okay.
Yep. Okay, and now how are you gonna find your expression for range.
Sub it into x.
Yep.
X
Okay.
equals v times 2v on g root 2 times cos 45.
Yes.
X equals 2v squared on g times root 2, which is just 2.
Yep. So on 2g.
So that cancels out, and x equals v squared on g.
Yep. So then remember, we're trying to equate to r on 2. So what can we say r on 2 is?
Oh, right. Therefore, r on 2 equals v squared on 2g,
Yep.
which is
That
just
does. Yeah.
that.
And now it looks the same.
Okay.
And then we've proven it. So yeah, your idea was right. It's just find the general expression first, and then you can plug in that 45.
Okay.
Cool. Okay, that's not everything. We have part B. Hold on. So we'll just run through part B, and then it'll just be general Q&A. Okay. So part B, if tan alpha equals 3 on 4 and V equals 196, so these are given to us now, what time must elapse between when the two particles were shot if they collide as they hit the horizontal plane? So what it's asking you is basically to find the time in between when the two particles were shot. I'll give you like 30 seconds to think about it and maybe get a little start.
So
Yep.
would you just sub? So you have the range formula, and you know what the time is from part A. We worked out the time when it's at y is 0.
We solved for y dot equals
Oh.
0, not y equals 0. So just to get your start on this question, think about, so it's telling you that the particles collide when they hit the horizontal plane.
So y equals 0.
Yep. But also think that it means that, like, say your equation for your x displacement is going to, for your first particle, is going to equal your equation for your x displacement of your second particle. So let's start by writing out, let's say for the first particle that was shot, we'll call it, this one is the one that shot at like the angle of alpha. Can you give me the equation for its x displacement and its y displacement in terms of, and thing to keep in mind here, so we'll call TR the time for the first particle to collide with the ground.
Okay. So the x displacement is 196 t cos of TR cos of inverse tan 3 on 4.
Yep. Now, is there a way to use this to find what cos alpha is?
Is it just 4 and 5?
Yeah, it should be. Because if you sketch it like this, then yes, it should be
Yeah.
4 on 5. Okay, so we'll just write it in as 4 and 5. We'll simplify it in the next step. So, what the hell? Okay. Oh. It's like, let's tweak it out. Okay. Interesting. So 196 TR times 4 on 5. Okay. And if you just simplify the 4 and 5, multiply it in.
784 on 5. Oh, this is 156.8.
Yep. So 156.8 TR. What about Y?
Equals 3, 4, 5. 196 TR times sine theta, which is 3/5,
Correct.
minus half G TR squared.
Yep. So I'll just call that 4.9 for the G on 2. Okay. And then apply the 3 on 5 multiple.
117.6 TR.
Yep.
Minus 4.8 TR squared. 4.9, sorry.
Yep. Okay. Now, what about the second particle? So this is the one that shot at an angle of pi on 2 minus alpha. So just turn all your sines into causes.
Okay.
Before you go into the equations, though, what do you think your time for this particle is going to be? So for the first particle, we said it was TR.
Thing.
What do you think it's going to be for this one?
Do TR.
Will it be, though? Because what do you think the T in the equation represents? So like going back to like the question info, what do you think this T here represents? Is it time from some initial starting point, or do you think it's like time of flight or something else?
Time from the starting point.
Close. It's time of flight.
Oh, okay.
So, considering that it's time of flight, okay, so we say T equals time of flight. What is the time of flight of the second particle going to be, given that it lands at the same time that the first one does? It's a bit of a like brain,
Will
like
it
it's a
be
bit interesting.
faster?
Pardon?
Time of flight of the second particle will be shorter.
Yes, it will be shorter.
Yeah.
So that's exactly correct. So one way
So
we can write it,
does that just mean they're not projected at the same time?
they aren't projected at the same time. It tells you that the second one is projected after the other.
But how are they projected at the same time and land at the same time, but they have different flight times?
No, they're projected at different times and they land at the same time because they're shot at different angles.
Oh, right, right.
Yeah, the different angles is what makes them land at the same time.
Mm-hmm.
So the way we're going to express the time of flight of the second particle is this TR, so the original flight time, minus T. And this T here is what we're going to be solving for. This T here is what I will say is the time elapsed between shooting the first particle and shooting the second particle.
Mm.
Okay, does that make sense?
Yeah.
Okay, so now can you set up the equations for the second particle for displacement?
going to be 196 TR minus T
Mhm.
times 3/5.
Yep, you've just switched the
Yeah.
cos into a sine. Yep.
That's just 117.6. Should I expand or just leave it in the brackets?
Leave as is.
Here, TR minus T.
Yep.
And then Y equals 196 TR times 4/5 minus 4.9. Oh, what about TR minus T?
Yeah, I know what you mean.
Yeah, 4.9 TR minus T times 3/5. Oh, wait, no, never mind. There's no sign cos. That's it.
So what did you say it was minus 4.9 TR minus T?
Yeah.
Should it be squared or not squared?
Oh, also squared.
Yep, cool. And just apply the 4 and 5 multiple.
Yep. So that's 156.8
Yep.
TR minus T
Yep.
minus 4.9. Blah, 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 blah.
Yep.
Cool.
Okay.
So
I'll write that in once my
the
iPad stops lagging.
first x value is the same as the second x value, and then we solve for t.
Yep, but
Or do we solve for y is 0 first?
yes, so you can find TR.
Okay.
So which one are you gonna look at to do that?
The first one.
Okay, exactly. So doing that, what are you going to say is equal to 0?
0 equals 117.6 TR minus 4.9 TR squared.
Yep. And then you just solve for TR.
Yeah. Is it just 24?
I believe so. I'll check as well. Yep, 24.
Oh, that's nice.
Indeed. And now let's solve for T. So how are we going to do that again?
So the x of 1 equals x of 2 when
Yep.
you sub in TR is 24.
Yep. And so what x's are equal? So like what's the actual expression that's going to be equal?
156.8 times 24
Yep.
equals 117.6 24 minus t.
Cool. And now just solve for T. You'll get an interesting answer.
Is it negative?
Yes.
Yeah, I got -8.
Okay. Why do you think it's negative?
Oh,
Before
because 8 seconds after or 8 seconds before.
it's 8 seconds before, so what does that actually mean, like physically here?
So that just means the first particle was projected 8 seconds before the second particle.
Means the opposite because of the
Oh,
negative
okay.
sign. Yeah, because so what it means, so if this was +8, then it would have meant the second particle was shot 8 seconds after the first one, right? But because it's -8, so okay, I'm getting ahead of myself. So stepping back a second, we've assumed that the one that's shot at an angle alpha is the first one.
Oh,
That's the assumption we've made. So what this negative sign tells us is that it's the other way around.
okay.
It tells us that the particle that was shot at pi(2) minus alpha is the one that was shot first.
Right.
Because the -8, if you think about it, right, plugging like TR -8 gives you like 30 seconds. So this TR -8 is coming from the pi(2) minus alpha's time, which we said was like TR minus T, right?
Yep.
So this had a 30-second flight time, whereas our first particle, the alpha one, had a 24-second flight time, meaning that this one was shot first.
Okay.
Okay, that's all that negative means. So it's perfectly valid to have the 8 seconds. All you just say is the pi on 2 minus alpha particle was shot first, and 8 seconds elapsed before second shot. Okay.
Mhm.
All right, cool. That is all the questions. So does anyone have any questions for me about anything in this lesson or from previous lessons? Journal?
No, I already asked my question.
Oh yeah. Um, in that case, do you want to go through one last question?
Yeah, sure.
Okay. Um, let me just pull it up. So this last question is going to be an incline plane question.
Yeah,
And yeah, I'll get you to help me through it, Jonah.
sure. Oh, I've never seen one of these, but I think I know how to do it.
All right.
Is it
That's
just
great.
that the acceleration becomes uh like you have to find the components?
Um, let me well, component.
Like what changes about the inclined plane? It's just the acceleration, right?
Acceleration wouldn't change. Nor would velocity. It would be displacement that changes. Because
Right.
like the acceleration is driven by your forces. You still have the same
Wait,
forces.
but it doesn't it kind of looks weird. Like
That's just how it's drawn. But yeah, that's just kind of like poor drawing. It shouldn't look
yeah, it looks like this is the
yeah, it shouldn't look that
yeah,
chunky.
okay, right.
Um what actually varies will be displacement. Everything else is the same.
Okay. Um okay, that makes sense. Diagram shows an inclined plane.
But for the first part of the question, where you're just looking at the path of the or like the trajectory of the projectile, it's actually um I think it's separate to the inclined plane. You don't even need to consider the inclined plane in part A.
Yeah, yeah, I don't think so. Tan uh wait, what's this? The path of trajectory. So that's a y, the y, like wait. What is
Okay, I'll give you a little starting point. So I'm gonna say we're going at a starting velocity of v. We're shooting at an angle of theta. We can say the acceleration in the x direction is 0, and the acceleration in the y direction is negative g.
yeah.
So what I want you to get to is an expression from integrating this to an expression for x displacement and an expression for y displacement, and then we'll go from there. So I'm just this is just for you guys' reference. I'm just pasting the homework questions as well that I've set.
So it's just
Mm-hmm.
wait, I do physics, so I can just use the Suvat equations, right? Like if I know them.
You
Because the answer is S equals UT plus 1 on 2 minus times
Mm.
minus 9.8 T squared, right? Like that's for what for Y. And then
what'd you say again? Repeat that.
S
S
equals
equals
UT
U. Yep.
plus 1 on 2, and then X is just S equals UT.
Yep. But what is your U gonna be?
Oh,
You can use
well,
that. It's just when you do that, you need to be careful of angles.
with angles. No, like I know what it is, but it's
Yeah, if you know it, you
like
can skip straight to it. You don't need to do the deriving.
yeah.
So what would you say X, the X displacement is?
Like wait, what's the initial velocity? Is it V?
V. Yeah.
V cos theta.
Remember you said it was UT. So it should be
V
your
cos theta T.
yes, VT cos theta.
Yeah, yeah.
Yep. Okay. And what about Y?
Y is V T sine theta
Mm-hmm.
minus 4.9 times T squared.
Yep. We'll just call it G on 2, but yeah, correct. Okay. Now here's where we get to doing some funky stuff. So okay, also this question is slightly wrong, by the way. It should be X tan theta.
Mm.
We want to somehow in this equation here force a tan and force a sec. So
Okay.
it's really jank. Honestly, this is kind of one of those questions you know by doing. But from our X equation, what you can say is T equals X on V cos theta. Would you agree?
Which is sec. Is that
Yep.
sec?
Yep.
Yeah.
So that's going to be X on V sec theta. Exactly.
Yep.
Now, if we plug this into our equation for Y, you're going to get Y equals V sine theta
And then we get a
times,
tan. Right.
yep. So you're going to get X on V sec theta. So I'm just going to write this as cos theta here. Minus G on 2 times X on V sec theta squared. So this is going to give these cancel. You get sine theta on cos theta, which is just tan theta. So this is where you get your x tan theta.
Yeah.
Over here, minus G on 2, you get x squared. You get x squared. Like so.
X. Wait, is it X? Sorry.
Yep.
Wait, let me just. Is it XV? Oh no, V cancels. Is it? Oh yeah, right. Sorry.
Oh,
Continue.
good. Oh, good. Now you get to this point that we have where we're very close to what we're trying to solve, but what do we have that's extra in our current expression compared to what we're trying
Extra.
to get?
Wait, what's we have the G on 2.
Yep, the G on 2V squared. Now, is there something in the question that lets us eliminate that? Have a look for it.
Yeah, where it says assume this equals 1.
Yep. So
Yeah.
we can assume 2V squared on G equals 1, which means then we can assume that G on 2V squared is also 1.
Okay.
Because if you invert 1, it's still 1.
Yeah.
Yep. So then we can say that this equals 1. This is given.
And then we get the thing.
Yep. And you get the thing. Exactly.
Okay, nice. That's weird because like the question, there's more to this question, right?
Yes, there is. There is.
Yeah.
Yeah, the next part is finding an expression for range up the inclined plane.
Yeah, okay. Yeah, I thought it'd be that.
Yeah. We don't have time to go through it probably. So I'm just gonna put it in here with the answer so you can see like how I worked through it. So this will be part B, just on the right. Yeah, you can have a quick look through it in like the last minute and see if you have any questions on what I did.
I think it's pretty straightforward. I probably would have gotten it, I reckon.
Yeah,
Well, I'll try it for homework as well.
yeah, I reckon have a crack at it. It's the only thing you just need to remember is how to do like the sine angles, like the sine theta minus alpha. But you can remember that from formula sheet. So
Wait, the sine
it's just
sine
the
theta.
it's just
Yeah.
yeah, it's just the last line. You can formula sheet it.
Right. Yeah, I know. Okay.
Yep. Okay. Well, that's all from me. So if you have any last questions, you can ask me. If not, then we'll wrap up. Any last questions? No. Okay. That's all for today. So just for homework, if you look at the bottom, there's like 2 questions. So the first question is on rates. The second question is on projectile. So it's just those 2, and then have a crack at the HSC mock exam 1. Not expecting you to get all of it done, just get as much as you can done. I understand you guys are busy.
Okay.
So yeah, and then we'll just go through like some select questions for next lesson in that. So have a go at those, and if there's any ones you struggle at, or struggle with, just note them down. We can go through them next lesson as well.
All right.
All right. Good job, guys. Enjoy the rest of your week.
Thanks.
Have fun.
See you
ya.
later.
See ya.